process. Okay? This process is the biggest part of conversions. Pretty much everything that you do within Chapter 2 is relatively straightforward as far as a calculation. Sometimes you can memorize and come up with a formula to go through it. Okay? My recommendation is to not attempt to memorize a formula. The recommendation is to follow a process. So what we're going to go through and do is the process for every time we go through and solve something. Okay? So, do you guys want to attempt to set up your process for this one? Or do you want me to show it first? Show it first. You may regret that in a second, but that's okay. So, step 1, what do we want? Okay. We want grams. It is not as important, and we don't have to specify the RAMS because G is our abbreviation. At this stage, the substance is less important because the substance is going to be the same in these conversions. Okay? For this unit, the substance doesn't change on us. It's always the same substance. Okay? So the substance isn't quite as important. But it's not a bad idea to get used to writing that in. We could say ASP for aspirin. Notice again, I'm abbreviating because I'm lazy and I don't want to write it all out. Okay, what's the next step? Provide or write down what you're given. Okay? This is where some people get irritated with me because we're going to start to get into the kind of nitpicky details on what you should be writing. Okay? What is the given information? No. Milligrams of aspirin is what is given. Okay? This is, again, me being nasty and nitpicky. Milligrams of aspirin is what's given. What is the number associated with the milligrams of aspirin given? 325. Note the steps, okay? And we can, I don't think I've got enough colors to color code each and everything, but we'll try it. Okay? Each step, we're getting a new color. Okay? Is milligrams of aspirin the same thing as grams of aspirin? No. Which means I have to do something. Remember, this is a balancing. The left and the right must equal each other. Okay? So I have to add something in here to help these two sides balance out to the same thing. Okay? Or to the same unit. The only thing I'm allowed to change is the left-hand side. Okay? So that means I have to put something else in here. That something else is now a fraction. Okay? That fraction is what's allowing me to change the unit of milligrams of aspirin into grams of aspirin. Okay. What something should go in there? Okay. We have a suggestion, and so we're going to break it down very, very slowly. A suggestion to put grams on the top. Okay. My argument is I wouldn't immediately go there, but it doesn't hurt to go there first. Why did you put grams of aspirin on the top?
Because milligrams has to cancel out. Right? So
You put grams on the top because milligrams needs to cancel. So let's pause on that. Do grams and milligrams have anything to do with each other? No. So I don't accept your answer, okay, your explanation. And I know where you're going, but that's the next part. We started with grams of aspirin. Why are we placing grams of aspirin on top?
Because grams is what you want as a numerator.
When you look to the answer, grams of aspirin is on top. It's in the numerator. That's why placing grams of aspirin on top in our conversion factor makes sense. Okay? So there's a reason behind why you're placing it there. Okay? And we have to be very careful to understand the exact reason for it. Make sense? Okay? If we continue with the rest of your statement, you said milligrams of aspirin should show up on the bottom. And here I might be starting to run out of colors. So I'll just write it in white. Thank you, I appreciate that. We'll put milligrams of aspirin on the bottom.
I had my coffee this morning. I am ready for this.
I appreciate it. Why did you place milligrams of aspirin on the bottom? Okay. I want milligrams of aspirin on the bottom so that it cancels the milligrams of aspirin in the given information. Okay. So that's the logic behind the placement of those units. Okay. The next step is we have to decide, is there a conversion factor that allows me to relate those two? Yes. What is that conversion factor? Say that again?
1,000 or 10? I don't know.
Okay, we'll come back to that. Okay. There is a conversion factor that relates these two. And in fact, there's ultimately two conversion factors. Okay. There's the conversion factor that I told you to go through and memorize. What did I tell you? Milli means 10 to the negative 3. Okay? So since I'm looking at milligrams, 1 milligram is 10 to the negative 3 grams. Okay? Now that I have that equality, I can take that numerical information and I can sub that back up into my equation. Everybody okay with that? Okay, so let's do so. Where does the 1 go? With milligrams. So good. Enough people have gotten used to me yelling at them that they didn't say it goes on the bottom, because the 1 doesn't go on the bottom. The 1 goes with milligrams. Okay? Again, a very subtle but important distinction. The 1 goes here. Oh, I didn't change the color right. Oh, well. Does pink work? It still looks purple. Whatever, it's pink. Okay. That says, Mike, this is all pink now. What goes, where does the 10 to the negative 3 go? With the grams. In this memorization process, the power of 10 will always go with the core unit. Which is a core unit? Grams or milligrams? Grams. Okay? Another word for core that we could use is the root unit. Okay? What happens if we tried to run this calculation? Well, the milligrams of aspirin would cancel each other, and we'd be left with grams of aspirin. Well, what did I want to get for an answer? Grams of aspirin. Do I have the proper unit? Yep. Now I can do the math. Okay? In that math, what I would recommend you do is you take everything in the numerator and you enter it into your calculator. 325 times 10 to the minus 3. You write that numerator down. Then you take everything in the denominator and you multiply it out. Right? Then you write that under the previous answer. Then you do the division. Right? The reason being is that if we have longer calculations, okay, and we say 325 times 2, now divided by the denominator, and the denominator had 6, 15, 43 in it, and you said just divided by 6 times 43 times 15. According to the order of operations in the calculator, if you didn't put parentheses, you ended up not doing the full division. Okay, and we'll see that with a more advanced calculation, hopefully here in just a little bit. Does that make sense? Okay. Before I actually make you do more practice on your own, I want to talk about the maybe standard conversion here, because a couple people mentioned the other conversion between these two. Okay? This is a standard process for dealing with that conversion factor, and it's okay. The issue that I have with it is that it's not consistent. Okay? So there was a suggestion that milligrams to grams, that there are 1,000 milligrams in 1 gram. Okay? Is that true? Absolutely. Okay? If we shift this out a little bit more, okay, so well, let's actually, before we get to the shifting out, why might we use Mike's method versus the standard method? Why is the standard method now a standard method as opposed to Mike's method? How many of you like powers of 10?
Nobody.
Ooh, how many of you like negative powers of 10?
Even less.
Okay, even less. Why? Because when these conversion systems were set up, what did we not have access to? A calculator. What do you have access to? A calculator. You don't have to memorize extra information, and that's the problem with the standard method, is that you'll end up finding that that number, okay, our non-1 number, can change locations depending on which unit conversion we're doing. So you have to memorize more information if you use the standard method. If you memorize it and you're correct, I can't complain. The problem is when does that differentiation happen? And it ends up being a 50-50 chance. So if you are consistent and 100% of the time you always know how to do your standard method conversions right, cool, I'm fine with that. If you're inconsistent, you get to decide what is consistent enough. Is 70% correct consistent enough for you? Yeah? Okay. Then that's your choice. Right? My issue is that because it oscillates back and forth, most students lose track of that, and it ends up dropping to a 50%. I'm not happy with a 50%. Okay? Question?
I was answering myself.
Okay? So, we don't like powers of 10. Tough, we'll deal with it. What is 1,000 to a power of 10? 10 to the third. Okay? So, the power of 10 is there. Why did we write it out as 1,000 instead of 10 to the third? Nobody likes powers of 10, so we wrote it as 1,000. Okay? Is the minus sign actually there? What did we say the minus sign meant?
Less than 0.
In an exponent, it means do the calculation in the opposite location of where it is. Okay? Which means that calculation needs to be run in the denominator. Okay? That's what's causing the shift in locations. Okay? So it's all there, but because we can't process powers of 10, we can't process minus signs well, someone said there's got to be an easier way that I don't have to deal with that, and they just shifted it over to the other side of the equation, and they made the number a number that was easy enough to work with. Okay, 1,000. Okay, so that method isn't wrong, but you have to know more information to use it properly. Okay, and not just in this case, but in other cases. Okay, kind of makes sense? Okay. So, we've got it all color-coded out in the sequencing we'd go through. If we wanted to go through and do the math on this, okay, we get 325 times 10 to the minus 3. Okay. Because it's a power of 10, I need to shift the decimal. Okay. Is my final answer supposed to be smaller or larger? Smaller because it's a negative sign, which means the decimal point needs to shift in such a way that my number becomes smaller, which would mean to the left. 3 shifts, my answer becomes 0.325 grams aspirin. Is there anything else we have to be concerned about when writing our answer?
Unit.
We have our unit.
Sig figs.
Sig figs. Okay. So sig figs, we'd have to go back to our calculation and say how many sig figs in each of the steps through that calculation. So how many sig figs in the given first number? 3 sig figs. How many sig figs in the next one?
Oh,
It's infinite. This is a definition. Those numbers may look like just 1 sig fig. We even heard a suggestion for 2 sig figs because of the 10. Okay? But that is a definition for how we would convert between those two. As a definition, they're infinite sig figs. Okay? For the sake of this class, you should always use the given information. Your conversion factors should never change the precision of your answer. They shouldn't. Okay? Kind of make sense? Your turn. Some common things that I saw floating around. Okay, so the first thing I saw was something along these lines. What did I just show? An equal sign. Where's that equals written? Is that where I normally show my equal sign? No, where do I typically show my equal sign? I show it more to the right. Okay. Is it wrong to show it somewhere in the middle of the page or not to the extreme right? No. How many conversions do you have to go through and do for every conversion question? As many as it takes. If you put an equal sign in the middle of your page, but then you run out of space because you haven't done enough conversions, you start doing multiple lines. The instant you start shifting off of the main line, increases the odds of making a mistake. This is why when I write out the equal sign, I'm always writing it to the extreme right because I don't know how many conversions I'm going to have to do. Okay? And there are cases that when we go through and work things, I'm doing so many conversions, I have to shift lines because I'm writing too big. Okay? That increases the odds of making mistakes. Minimize that by always writing your equals line to the far right of the page. Most of your papers have two lines, right? The little red vertical lines. Put your equals on that far right red line. Okay? Subtle thing, not a big deal. Okay? But I would recommend that. The next thing that I saw. Wasn't that true? Didn't we start with 325 milligrams? Okay, we can throw in aspirin. Fair enough. Touche. I'll accept that.
Given we want to start with what we want, right, the desired.
All about the process. That is correct given information. But what's wrong with writing that?
You don't know what you want.
I don't know what I want. Okay? In your work, you should always know what you want. You shouldn't start a process if you don't know where you're going. You don't pull out the hammer and the nail and just start putting nails in things because, well, maybe you're trying to change a tire. So pulling out the hammer and nail, just because you had a hammer and a nail, doesn't help you to change the tire, right? So you have to know the goal. What are you trying to get to? And while it is a simple, subtle, and potentially silly thing to do, that's what you should be doing this, because it helps give you that logic, the flow of the direction of where you want to go. Whoops, I don't want milligrams. What do I want? Micrograms of our aspirin. If you don't like the micro symbol, that's okay. You could always write out micro. Okay. If you move into pharmacy and other things like that, they do other kind of simplifications for that. Okay, so now what do I start with? The given information. What was the given information? Ooh, milligrams, good. Dipsticks. Yeah, this number, yeah, go away. No.
Or solicitation. Elections coming up, they're calling us too.
Oh, yeah, that's right. Remember, I got yelled at for that. I gotta never do that again. Okay, so that's what we're given. So now the next step. No, I recognize that number as the weird one that just calls. Okay, milligram is not the same as microgram, so what do I need to do? Convert. Okay, so what do I decide to put into that conversion?
Milligrams at the bottom, which you want to get rid
Okay, so in the previous case, we started with what we wanted and place that in at the top. Usually most people will try and get rid of the thing that they don't want first. So I want milligrams on the bottom. Okay, and officially milligrams of aspirin. Okay, the hope always is that we do this conversion in how many steps? One. So the hope is that I could then put micrograms up here of aspirin and be like, ta-da, I'm done in one step. Okay, if you're a smart person and you can do powers of 10, great for you. Is that a given conversion factor? No. So that conversion is invalid. We don't have that information. If you don't have it, you can't use it. Okay? What information do we have? I can go from milligrams to grams, and I can do that because you were told to memorize the conversion. What does milli mean? And in that, you memorized that milli meant 10 to the negative 3. Where does the power of 10 always go? With the core unit. Where's the core unit? So it goes here. What number shows up in the denominator? 1. Okay. Other people have shown different methods through here. Those methods are equally valid as long as you do it consistently. The problem is consistency in what you're memorizing. Okay? If we ran this calculation, what unit would we have? Grams of aspirin. What unit do I want? Micrograms. Is that the right answer? No. So what do I need to do? I need to do another conversion. Okay? In that conversion, what needs to happen? We need to get rid of grams. What do I want?
Micro.
Micrograms. Is that a conversion factor that I have?
Yes.
Yeah. Okay. I know micro is 10 to the negative 6. What is 10 to the negative, or where does the power of 10 go? With the core unit, which is grams. So I put my 10 to the negative 6 in front of grams. Okay? The 1 goes up there. Where this becomes problematic is, again, how you go through and do this. If you say that power of 10 goes on top, what happens in this very next step? Then you put it in the wrong space. So this is why I'm being insistent on where does the power of 10 go? Where do the numbers go? Tie them to the units. Not the location, the units. Because the units are going to help you solve this. It is all about the bloody units. Okay? Now that I've got my calculation set up, I could go through and punch this into the calculator. I would get, come on, reconnect. Not connected yet? 325, yep, times 10 to the negative 6. Sorry, negative 3. Okay, I enter that into my calculator. My calculator tells me that that is 0.325. Okay, I multiply 1 times 10 to the negative 6, and my calculator tells me, I'm not going to do that, I'm just going to write it as power of 10, that it's 10 to the negative 6. Okay, now I can enter in the calculator 0.325 divided by 10 to the negative 6, and I get the answer 325000. Okay, notice in that, where are the units? I didn't write them yet because the work dictated all my units for me. So since the work had that set up, I can now say that this becomes micrograms of aspirin. The last thing we should verify, sig figs. How many sig figs in this number?
3.
How do you know it's 3? Aren't there 6 numbers there? There's no decimal point, so those zeros are not significant. Okay, so there's 3 sig figs in our current answer. So if you had written this out decimal point, you're now saying there's 6 sig figs. So we'd have to go back to the work and check how many sig figs in our first number. 3, the next number. Infinite, the next one. Infinite. Okay. I don't think it was in this class, but the King Henry died while drinking chocolate milk. Did I actually get that one right?
Yeah.
Okay. That's awesome for powers of 10. Fantastic. Okay. I don't care. We're not teaching you powers of 10. We're using powers of 10 to help you with a process so that you can use that process somewhere else. Guess where King Henry died drinking chocolate milk is useful?
In that.
Only here. Only in metric conversions. Okay. Do you always do metric conversions? Is it metric to convert miles per hour into the time it takes you to get somewhere? No. Okay? So memorizing King Henry is useless information. Okay? Largely also because I don't have you memorize all the stupid prefixes. You only need 3. Milli, kilo, centi. Okay? So, the reading survey, just to address this, I've got to send you a permission slip thing at some point, and we'll do that at a different stage, but it'll happen. You should be seeing a survey pop up about your success or failure as a student within this class, like we did earlier in the semester, right? Everybody remember that? Okay, you still need to fill that out. It's another one. Should be a little bit shorter. It shouldn't take that long, 5-10 minutes. I think that's coming available this week if it didn't show up last week. Okay, it's just a simple survey. Just go through and complete it. Okay, you get points for completing it. Okay, so just do it. Okay? So the next part is everything metric. Okay, we have the American system or the imperial system, and we have the metric system. Okay? So not everything is metric. We have to be able to convert between these two. Okay, so we have to have a process to do that conversion. Okay, those are now not powers of 10. 1 inch, 2.54 centimeters. That's not an easy just straightforward shift of the decimal. King Henry dies very quickly there. Okay? 1 pound, 454 grams. Okay, so these get a little bit weird on us. What makes them extra weird is how many sig figs are in each of those conversions. Why not 1? We'll get to that in a second. Why not 1? Because scientists are inherently lazy, including our textbook. This is 1.00, 1.00, 1.00, 1.00. Why did they not show that? Sorry. Default. It's what they do. Okay? So 3 sig figs. Okay? Those are not definitions for the most part. Okay? Those are careful comparisons between those. And depending on how many sig figs there are, I may have to add more values. For the sake of this class, we're primarily concerned about 3 sig figs, which would be that many fingers. Okay? If we have 3 sig figs, well then those conversions are fine. We don't have to stress about it. But what if you moved into another class where 4 sig figs was the default? What happens to the utility of these conversion factors? They don't work. We'd have to find a new conversion factor that gives me that extra sig fig. Okay? Is that obnoxious and tedious? Yes, but that's what you have to do. There is one exception in that list. Okay? This is why we always love footnotes, okay, or the fine print. This thing is free after you pay us 20 bucks. Don't call it free. How many sig figs in the first conversion factor? 1 inch to 2.54 centimeters. It's infinite. Why is that one now all of a sudden infinite? I just made reference to the footnote. We'll go through and read the footnote. We assume 3 sig figs, okay, have different references to standards. These are not exact equivalents. However, we decided that this conversion factor was used so frequently that it was stupid to have to constantly pay attention to those sig figs that the imperial system or the American system said, you know what? Screw it. We're going to do it so much, we're just going to define it. 1 inch is exactly equal to 2.54 centimeters. Okay? Why did we not do that for everything? I don't know. Not me. Okay? But that one has been defined. Ultimately, all of your English metric conversion factors should never affect your final answer. Because if they're affecting your final answer, then whatever you used to take the measurement was useless. It was either too accurate, in which case you lost information, or it wasn't accurate enough, and those things aren't going to affect your answer anyway. Okay? So we want our conversion factors to always have at least the same amount of sig figs as our measurement. Okay? If not more. Kind of makes sense? Okay. How are you guys feeling with conversions? Pretty good? Do it. Bottom question. Length of an American football field, including the end zones, is 120 yards. What is the length in centimeters? Right? Usually, you don't talk enough to each other. Maybe I gave you too much time and you started talking to the people around you. You're like, but I didn't get that answer. 2 numbers usually come out of this. 10,968 centimeters, 10,972.8 centimeters. Okay? You all did the same work, and guaranteed your work was spotless if you got either of those 2 numbers. Okay? So if you got one of those 2 numbers, good job. Okay? Do we need to go through to solve to get either of those numbers, or are you happy with your method?
Why are they so different?
We'll deal with that in a second. So is everybody happy their conversions came out to one of those 2 numbers? If you got one of those 2 numbers, you did the conversion right. Good job. Okay. Why are they different?
Conversion?
Because the conversion from inches to centimeters is absolute, it's a definition. And the conversion from yards to meters is...
Yards to meters is not an absolute definition. inches to centimeters is. Why? Because no one sat down and said, this is the answer. Right? Could someone sit down and say, this is the answer? Unfortunately not. Once we've established 1 inch is 2.54 centimeters, if we tried to then convert yards into meters, okay, to deal with that system, even using exact conversions, we find out it doesn't equal exactly 0.914. Okay, it would equal 9.914 number. Just one more number? 4. Oh, cool. Just one more number, 4. Okay. So if we reported that extra decimal, then theoretically those numbers should now, or those conversions should converge into the same point. Okay? So this is why the English to metric system is a massive issue. Let's see it. Okay? So we have to be very careful in dealing with English to metric conversions. Okay? And where it becomes extra important is going to be the next question that I'm going to ask, which you might be hinting at. So let's go to your question.
Does that mean like the 1 yard to 0.914, that's only 1 sig fig?
Nope, that's 3.
Is 3?
That is 3. Yeah. The 1, they're always providing as a 1.00 to match whatever that is. Okay? And that's irritating, but that's what's happening up here too. Okay? They are assuming they're filling that out with zeros to match whatever that is. Okay? So yes, English to metric conversions are irritating. Okay? So that then gets to the question, which of these answers is right? Neither. They're both wrong. What's the last step after you run a calculation? Sig figs. Okay? This first one here has 5 sig figs. This bottom one has 6 sig figs. So we'd have to go through all of our work. Remember, theoretically our conversions should not be affecting the sig fig count. Okay? But in our conversion somewhere we had a conversion that was at least, that had 3 sig figs. So minimally, these have to drop to 3 sig figs. Okay? Those were our conversions. The conversions should not affect the sig figs. So we shouldn't be adjusting based off of our conversions. What should we be adjusting based off of?
Significant figures
The significant figures
in our
in the given information. What was your given information? 120 yards. How many sig figs in that number? 2. The 0 is a placeholder. How do I know it's a placeholder? There's no decimal point, which means both of these numbers are wrong because they have way too many sig figs. We have to convert them to 2 sig figs. So the 1 is significant, the 0 is significant. Okay? What's the issue? The first insignificant digit is greater than 5. So what do I have to do? I have to add 1 to the previous one. Okay? And so the answer becomes 11 centimeters. No. I have to include those zeros to make sure I get 11,000.
But then there's still only 2 sig figs.
There's only 2 sig figs here because no decimal point. If I want to be extra absolutely clear to make sure that those zeros are not significant, what could I do as a final step? I can convert to scientific notation. My first sig fig goes in the 1's place, followed by the rest of my sig figs. In this case, just the 1 times a power of 10. My implied decimal went 1, 2, 3, 4 locations, so 10 to the 4th. Was my number large or small? Large, so that's a positive 4 centimeters. Both of these are acceptable answers. You got it?
Yeah, I got it. So milli is 3, centimeters is 4.
So milli means 10 to the negative 3. Centi means 10 to the negative 2. Okay? And then, what's the other one? Kilo. 10 to the positive 3. Okay? You don't have to state the positive. You don't have to write the positive. I will always say it to try and add emphasis. Okay? Kind of make sense? Okay. Is this a big issue with metric? Okay? If we consider money, it's a huge issue. Okay? Allegedly, this was true. The U.S. saw the French made a really cool tank, and they're like, cool. Okay? Because we've got the massive industrial complex of steel and all this stuff. You give us the plans, we'll make your tank and sell the tank to you. Okay? Because we're better at making things than you. Because we have a better system built, the whole industrial revolution and all that. Okay? So allegedly this went through. The French are like, sure, build our tank because you can build it faster and cheaper than us, and then we'll just buy the tanks from you. So they transfer the plans across. What happens? 5,000 inches for a tank? That's really, really big. No, actually, we measured ours in millimeters, not in inches. Okay? Which means for the US to go through and build the French tank, what do they have to do? Convert all of the measurements across, okay, to make sure that it would then work in the French system. Okay? Or retool the entire factory such that it's in the metric system. Both of those options are stupidly expensive. So what happens? We won't do it. Okay? This is a big issue. Okay? This is why science does try to come to some middle ground, and it's unfortunate when we don't, both because now you're responsible for doing those conversions, and because we miss out on potentially lucrative options.
Why
Okay.
didn't we carry like
So one option is, why did we not carry one system over the other? Okay.
Stubborn?
Yeah.
Stubborn. Okay. It's a power thing. I'm more important than you, so I'm going to use a better system, or my system than your system. I'm not going to convert across.
Were we still using the
Right.
metric system when we moved over? Or did they create it
I don't think we
eventually?
were using the metric when we moved over, actually, because we came from England primarily. And England is what screwed it all up. Okay? Because an inch was the length of the king's thumb. So I'm pretty sure it was a British invention. Actually, no, that's a lie. I think it's a Greek one. It goes all the way back to Greece.
So somebody just
So-
screwed it up for everybody.
Somebody screwed it up for everybody. And ultimately, did they really screw it up for everybody? They went through and took a measurement. They invented a measurement system. It just happened the measurement system they invented, they didn't have the knowledge to see how widespread it would need to go, so they didn't have a logic behind that system.
Or accurate.
Somebody else went back through and said, well, I can see that this needs to be able to scale, and your system doesn't scale well, so I'm going to invent a new system that scales. Well, why didn't everybody just shift to, oh, that's a nice idea, it should scale nicely?
Because everybody's been on the other one for so long, they didn't want it.
Okay. We run into this issue across the board. The biggest comparison that we could go for this, if you become an organic chemist, allegedly, because I'm quoting somebody that may or may not have been telling the truth, the lifespan for organic chemists is on average 15 years less than the standard population. What? I'm an organic chemist. I just committed to living 15 years less than the rest of the population. Why is that? Remember the ACS safety video you were all to watch in the lab? And they were like, when you pipette, you use a pipette pole. You would never use your mouth. Why do you have to put that in a video? Isn't that kind of stupid to stick your mouth on a nasty piece of glass and suck chemicals into it? That's just an awful idea. No one would ever do that. That's the standard protocol. Okay? So all of the older chemists, that's what they did. Okay? Another fun one that I've heard from advisors, from my older advisors, okay, when they were in the lab and they got chemicals on their hands, how'd they clean them off?
Understand?
They used benzene. When you get a moment, look up the safety hazards of benzene. Okay? It's not pleasant. Yeah. Okay? Because benzene would dissolve all those chemicals off their hands, so they didn't have to worry about it. It also causes cancer. So they did a lot of kind of stupid stuff early on. And some of that is just you didn't know. Right? If you don't know, it's hard to avoid those dangers. Okay? Like when you're walking down the street and looking at your cell phone. You don't realize you're crossing into a busy intersection, you get hit by a car. Right? No one really has a lot of symptoms. Why are you looking at your phone? And yet every single one of you, including me, has probably been walking down the street looking at your phone. You're doing the exact same mistakes. Right? And it's until we hit those repercussions that we don't make changes. Okay? Unfortunately, where did that repercussion happen? So far down the road that now everybody has built a little bit of stubbornness, but now it's the industries built around those systems that would have to change, and that's very, very expensive. Right? Kind of like solar power. Kind of like electric cars. Okay? There's too much of an infrastructure around other sources of energy. We have to break that infrastructure before we can rebuild. Okay? So, separate question. You may have seen questions kind of like this, okay, in like a math class. Harry wants to exchange his pennies for dollars. Douglas likes silver things, and so only exchange his dollars for silver objects. What does Harry have to do to get his pennies converted to dollar bills, and how many dollar bills can he get? Okay, and then they give you this other, Harry has 100 pennies, Douglas has $3 bills, Sally has 30 dimes. Sally wasn't even in the question. Why is Sally mentioned? Dimes are silver looking, right? Okay, so there we go. So we could go through and say, well, Harry has to exchange his pennies for dimes with Sally. Once he has the dimes, he can then exchange his dimes for dollars from Douglas. Meanwhile, you as a student are like, this is just freaking stupid. Why are you making me solve a question like this? This is dumb. In the real world, Harry just beats up Douglas and steals his dollar bills. Maybe even throws his pennies at him. Say, here, take my pennies, I'm taking your dollar bills. And that's the end of it. Okay? Why do we have to solve questions like this? We aren't giving you questions like this in a math class just for the hell of it. What are we trying to help you do in the math class with a question like this? Build a process to solve the question. So that when this changes to a system that you're less comfortable with, you have the ability to do that conversion. Okay? Anybody have any idea what a Snorlaxi is? Or a Skittle fart?
It's when you eat too many Skittles.
Okay?
Chase the rainbow.
That is the natural conclusion of that statement, but no one's ever explicitly stated it. As soon as those unit systems change, that now becomes a less trivial thing for us to solve. But if we have a process, I don't care what the hell those things are. I know how to set up the problem solve. Does that make sense? Okay. And so in this chapter, that's kind of what's going on through it. Okay? We're having you do conversions that you should know how to solve. Okay? And you may think they're stupid and beneath you. That's fine. You're trying to establish that process. Because in the next unit, we move to units that, or unit systems that you have no clue what they mean. Right? And it takes time to be able to process to get to an understanding of what those unit systems mean. Okay? Meanwhile, we have to continue with content. So you have to be able to use that unit system before you've learned anything about it, or before you fully grasped what it means. Okay? So you have to set up conversion systems, and you have to be able to manipulate those before your understanding. Ultimately, because the understanding comes from working with it. Okay? You have to have a process that you trust to move through. Does that kind of make sense? Okay. So, more conversions. Compound units. Okay. What are the units for your speed of your car, your bike, walked class? Miles per hour. Okay. Miles per hour may seem like a number. Okay. But I would argue all that is, so we say mph, right? Miles per hour. Also written as 65 miles per hour. That notation is awful. Why does that notation exist?
Because that's what's actually happening.
If you were going to write some information down, how do you write it? You're like, what? You're going to use a pencil. Yes. You put the pencil to the paper. Where do you start? Where do you start every time you put the pencil to paper? To the left. Where do you end? To the right. Do you go down? When do you go down the page? After you finish going to the right. We write left to right. Okay? At least in this country, we write left to right. Okay? You type. How? Left to right. The problem with this notation is that mathematics is really saying that this is 65 miles over 1 hour. Why don't we write it like that? That shows clearly the fraction that allows me to do the conversion. That's too hard to enter into a computer. Okay? If you don't believe it, enter it into a computer. You will find it's a mess. Okay? Some people, which brings up an interesting point, some people have been doing some of these conversions and typing them in. I'm okay if you really want to do that. I think that's an awful idea. Awful because you have to deal with formatting, and number two, do you type things in when it gets to the exam?
No.
No, you have to handwrite it. By typing in your answers into the computer for our problem solves, you're breaking the muscle memory that you need for the exam. So I would recommend handwriting conversions so that you get the muscle memory so that when you get to the exam you can do those conversions right. Does that kind of make sense? Okay. So we have a fraction here. Okay. Ultimately, there's another way to write this. 65 miles equals 1 hour. Why did we write it out as 65 miles over 1 hour? Couldn't I have solved the other way, 1 hour over 65 miles? Isn't that also true? Yeah. Why do I not write it like that? Because it's a... We wanted 65 as our number and a nice easy place for us to interpret. Okay? What is 1 over 65? Okay, a fraction, that's a nice cop-out. It's a fraction, and I don't like fractions. Okay? Or you enter it into the calculator, you get this weird decimal. Does anybody like decimals? No. Okay? So why do we write it as 65 miles per 1 hour? Because I can deal with 65 pretty reasonably. That's a number that my brain can process. Puny human brains. Okay? Not your puny human brains, in general. Okay? So a motorcycle is traveling at 105 kilometers per hour. What is the speed in meters per second? Why would I change that? Okay, why would I ask that question? Maybe I need to know how many seconds it takes to do something.
You're looking at a smaller increment of time that you're trying to measure.
Why might a smaller increment of time be important on a motorcycle?
Because you're trying to win a race.
You're trying to win a race.
Or
Someone cuts you off. That cutoff process, what's your reaction time to allow for that? Okay? So you need a smaller increment of time to do a processing there. Okay? Ultimately, why are we asking you this question?
practice conversions.
Practice conversions. And ultimately not conversions, practice
The process.
the process. Okay? You should be able to do this conversion relatively quickly and easily and trust whatever method you're using. Okay? And again, I don't care necessarily what that method is, as long as that method shows the units and the process behind it. Okay? So in this case, what am I solving for?
Kilometers per second.
Meters per second.
Meters per second. It's okay. Meters over seconds. Note again, I'm not doing meters slash seconds. Meters over seconds. Okay? What am I given? I'm giving kilometers per hour. Why did I place kilometers in the numerator? Right? Why did I do that? Couldn't I have just as easily written?
Because that's what's given.
Is that also not what was given?
No, because distance is the numerator.
Isn't this given information?
Yeah, but now you're wanting hours per kilometer.
Why is this a bad place for my conversion factor?
It's not what you want.
What am I trying to get to? Meters. Meters is a measure of distance. Seconds is a measure of time. Hours is a measure of time. Where did I place the time measurement? In the numerator. Where do I want it? Denominator. So recognizing what your unit systems are measuring can help you place your units and decide what to start with and where to place things. Right? So I could go through and say I want kilometers on top because kilometers is a measure of distance, and I want distance. I'll put hours on the bottom because hours is a measure of time, so I want time in the denominator. Now I can place my numbers. What is the conversion factor between kilometers and hours?
105 kilometers per hour.
It tells you in the question. 105 kilometers is 1 hour. Notice again we have the slash here. Why do we have the slash here? It's typed. We have to interpret that typed information into a fractional formation that allows us to solve the question easier. Is kilometers the same thing as meters?
Oh, no.
Oh, sorry. Is hours the same thing as seconds?
No.
No. So we have two different units that we have to convert. Which unit do we choose first?
Hours, seconds.
Doesn't matter. Right? Because ultimately, to do the conversion, you're doing multiplication and division. And multiplication and division are communicative processes. It doesn't matter the order in which we do them. So I could go through and do hours. What do I want to convert hours to? Seconds. Anybody know that conversion? Put your hand down. Most of you don't. What does that mean?
That's 2.
That we can't do that. I don't know that conversion.
10 minutes.
We know minutes.
Okay? Why are you deciding to go minutes instead of changing the hours?
It's easier.
Okay? Or sorry, because we could have done minutes. Because we had what? Let's go back to this, sorry. Hours over seconds. What did I go through and erase? I erased seconds to put minutes on the bottom, right? Okay. Couldn't I just as easily? Oh my gosh. Done this? Hours. Whoops, I wanted. God. I know where I want to go, and I'm not getting there. Hours, seconds. We said we could bring in minutes. Okay, I got it. Trust me. I went through and said minutes on the bottom. Right? Did we have to do minutes on the bottom?
Yes.
You're telling me you don't know that conversion?
But you have to get rid of the hour.
Right? This conversion is going to happen. The question is, when does it happen? Why do I want to do it? I would make the argument that we don't have a reason why to do this yet. Okay, why not? Trying to get rid of hours.
Minutes doesn't get rid of hours.
Minutes doesn't get rid of hours. Okay? There's a logic behind why we put in a conversion factor. It's not just that I'm going to do a conversion and I know it needs to happen at some point. Because ultimately what that means is you knew the answer. If you knew the answer, you shouldn't be doing it. Okay? So I want hours and I'm going to go to minutes. Make sense? What is the conversion factor between those?
60.
60 minutes is 1 hour. Okay? Are you expected to know that? Yeah, we never talk about it. There's some things you're expected to know. Okay, what happens? Hours cancel. Fantastic, that's cool. We fixed something. Okay? Did we fix it all the way? No, because I'm in minutes now and I want seconds. So what could I do?
1 minute.
I would put minutes in the numerator because I want it to cancel. And I would put seconds in the denominator. Do I know that conversion factor? What is that conversion factor? Where does the 60 go?
With the seconds.
Okay? Make sense? The minutes cancel. Cool, we've got seconds, so I've got my answer. All I got to do is enter it in the calculator. No, why not? Kilometers hasn't been converted. Okay? So now I've got to go through and deal with kilometers. Kilometers needs to get converted to meters. Yeah? Am I required to know that conversion? Kilo, I'm required to know is 10 to the third. Where's the 10 to the third, or the power of 10, always go? With the core unit. Which one's the core unit? What happens? Kilometers cancel. What would my units now be? Meters over seconds, and I now have my answer. Okay? Entering this into the calculator. 105 times 1. 105. You don't want to do that in your head. That's cool. Enter it into the calculator. Times 1. Still 105. Times 10 to the third. Okay? Your calculator spits out a number. In this case, it'll be 105,000. Okay? Divided by 1 times 60.
60.
Times 60.
36.
Times 1.
36.
3,600. Okay? Now I can do the division in the calculator. 105,000 divided by 3,600, and I get my answer. Okay? That way, I've streamlined that process and I minimize the order of operations mistake that could happen within it. The other option is dropping parentheses around both the numerator and the denominator when you run your calculation. So you either get used to using parentheses or you break it into those individual steps. I've used both methods and I seem to prefer to break it into individual steps. Okay? But that's personal preference. We good? Do we need to do more of those?
So your final answer,
I don't know. I can't do that division.
but like you would say is
Maybe I can. Is it? No, it's not that. You'd say is what's our answer?
It's
29.1666666.
1, 6,
66.
6.
So, and you would say,
so it'd be.
what? There's a seven.
There's more sixes. Yeah.
There's a seven.
Well, that's 'cause
Is that answer right?
No.
No.
Now you do
We'd say
six.
3 sig
Why 3 sig figs?
because it's given.
We were given 105 kilometers per hour. That's our start with 3 sig figs. The conversion factors in between were all definitions, so those are all infinite sig figs. My answer needs to be reported to 3 sig figs. 291. The first insignificant is larger than 5. Add 1. 29.2
And then it's meters per second.
meters per second.
Okay.
Get it? Okay. So every time you set up one of these conversions, this is one of the things that's a really, really big deal. When you look in the textbook, they show you this. If you look at your notes, you see this. We did not start with this. We talked through each of those individual steps of why you're putting something in. It's that question you must ask yourself every time you solve. And if you put something in, you're like, I have no idea why I put that there. You need to figure out why. Okay? And you need to figure out now why, because now you have a concept of what these units mean. You know that minutes are smaller than hours, so the 60 goes with minutes. Okay? But as soon as we switch the unit system, you may not know that information. You have to trust the process. Okay? So we're at that kind of 5-minute warning. The rest of these is just more examples of the same thing. Okay? Just doing conversions across, coming up with a process that works for you consistently. Okay? I'm more than happy to work through a bunch of examples of this kind of stuff in the tutoring center. I wouldn't pack up quite yet because we still got stuff to kind of move through. Okay? There is an example there at the bottom, so you could go through and do that one. Volumes, okay, in 3 dimensions. Okay? The issue with volumes is that we get a larger unit system to work with, or a different unit system. We use volumes because of liquids. Okay? Volumes came about because I could build a container to contain a liquid. Okay? And I could have that container measure things. So what we did was, what container would be easiest to measure in? Well, probably something like a cube. Why? I can get the volume, okay, relatively easily by taking the length times the width times the height. Okay? I could do that with a cylinder too. Anybody know the volume of a cylinder? Wow. Good. I think that's right. That sounds good. Okay. I don't know it. I don't expect you to know it. There's a formula to figure it out. Okay? The whole point is that what we're trying to recognize is that volume can be related to a measurement of length. Okay? Length times width times height. Okay? So has anybody heard, doctor shows 50 cc stat? It's a lot, but half a cc stat. What are they saying? cc. What is cc? Cubic centimeter. If we looked at the volume of this object here, what would that volume be? Well, 10 centimeters by 10 centimeters by 10 centimeters is 1,000 centimeters cubed. What does the word cubed begin with? C. What is cc? Cubic centimeter. Okay? So cubic centimeter is the distance measurement for volume. Okay, that's it. Okay? Turns out that 1 cubic centimeter is equal to 1 milliliter. you could go through and establish that conversion factor, okay? Because our definition for 1,000 cubic centimeters is defined as 1 liter. Okay, we now have a conversion factor. We could see how milliliters tied to cubic centimeters. Okay, that is a standard conversion for you to work through, not a tricky one. This becomes a tricky one. Okay, why does this one become tricky? Okay, if we go through to real quickly set this up, 498 centimeters cubed, and I want inches cubed. Okay, well I could say inches, whoops, might be helpful if I place it in the right place, huh? I want to get rid of centimeters and I want inches, right? Is there a conversion factor between centimeters and inches? What is that conversion factor? 2.54 centimeters is 1 inch. You're not responsible for memorizing that, so don't panic. Okay. But it says cubed. Okay, so cubed. Okay. If I drop in the parentheses, it's okay. Or I could do it 3 times. Okay. So this is not 498 divided by 2.54. It's 498 divided by 2.54 cubed, or divided by 2.54 divided by 2.54. Okay. So your real calculation is 498 divided by 16 and change. Okay, to get your correct answer. So be careful with your conversions when you're dealing with length measurements with volume. Your compound units get in the way. Okay, I know we're close. I just wanted to point out, we'll skip the volume of those. Density is just a conversion factor. I do expect you to be able to manipulate that on the exam as a conversion factor. We won't do interpretations of density. Temperature will not be on the exam. That's the biggest thing. Temperature's not on the exam. The meaning of density is not on the exam. We'll deal with that in the next unit. So we aren't horribly far behind.